To design efficient water storage schemes, engineers must have access to many years of reliable data on the flow of a river. The existing network of river gauging stations in Western Australia is being expanded as fast as resources will allow, in both the developed and undeveloped areas of the state. River gauging commenced in the southwest about 1900 and has extended recently into the Timor Sea and the Indian Ocean drainage divisions. The network of stations provides information on the quantity and quality of flow, the size and occurrences of floods, and the duration of periods of low flow or complete drought. In rough country, it can be difficult to find suitable positions to site stations and to provide access to them. It is often necessary to carry out preliminary investigation by air and follow with more detailed investigations of potential sites from the ground. In Western Australia, the Public Works Department operates 150 river gauging stations continuously throughout the year. Huts and airstrips are constructed at the more remote stations. Field parties based at remote stations are in contact with outside control by radio. Although he relies heavily on his motor vehicle, the hydrographer must sometimes use other forms of transport because of the risk of being marooned by floods. For example, increasing use is being made of helicopters in the north. The helicopters are used to ferry parties into and between otherwise inaccessible gauging stations as an alternative to leaving the Part 1 station for the duration of the wet. Helicopters are used to serve as unmanned stations, allowing the hydrographer to check the operation of the river level recorders. River level is measured by recording the pressure required to maintain a constant flow of nitrogen through an orifice positioned at the river bed. The level is recorded by a pen moving across a clock-driven chart, producing a continuous graph of level measured against time. In many cases, recorders are required to function efficiently over long periods with little attention. To ensure that no valuable records are lost, the hydrographer must check thoroughly the operation of the instrument. To determine the flow in a river at any time, the relationship between river level and flow must be known. In situations where weirs of simple shape can be built, this flow to level relationship can be calculated. On larger rivers where weirs are not practical, the relationship is controlled by the shape of the river channel and can only be found by flow measurements at each situation. Thus, as well as a river level recorder, the station must have facilities for flow measurement. Most of the necessary equipment is portable and is assembled at the gauging site. Here, a traversing winch is being bolted to the travel-away post and connected to the current meter, which is used to measure flow velocities. Before commencing measurements, the river level is read from the recorder chart. Measurements start near one bank, and soundings of depth and measurements of velocity are taken at intervals across the river by moving the meter along the suspension cable. At each interval, measurements of velocity are taken at 3 particular depths to determine with reasonable accuracy the average velocity at each interval. The velocity is measured by timing the revolutions of the propeller. From these measurements, the total flow of the river at that level can be calculated. The plot of these calculated flows against their respective river levels gives the required flow to river level relationship and is called the rating curve. When the flow is small enough, the flow measurement can be made by wading. Wading measurements are made with smaller and more sensitive current meters held in the hand and positioned relative to a tape stretched across the stream. The principle is the same as before, but the meter is moved up and down on a rod rather than suspended from a cable across the river. This method is used on larger rivers when wading is safe. From time to time, the meter is checked for free movement. All measurements are carefully recorded with other information useful in establishing the rating curve. On the larger rivers in the north, the basic procedure is again the same. However, the width of the rivers is sometimes so great that the operators travel out over the river in specially designed cars on a suspension cable. 2 operators are required to man the car. One operator winds the car into position. Each turn of the handle is registered on a counter so that the position of the car along the cable is known. The second operator lowers the current meter by means of a winch, measuring depths from the water's surface. The meter is positioned and the velocity measured by timing the revolutions of the current meter propeller as before. When in flood, some northern rivers carry an enormous load of sediment. Much of this sediment would be trapped in reservoirs built on these rivers. It is necessary, therefore, to sample the water at frequent intervals to determine the quantity of sediment in the flow. The sediment sampler is lowered into the flow in the same manner as a current meter. The river water is drawn through a nozzle in the sampler and collected in a bottle. A great number of samples must be taken so that the long-term average sediment load of the river can be estimated. The water samples are sealed, labeled, and sent for analysis. The sediment is separated by vacuum-assisted filtering through an extra fine filter pad. The sediment is then dried in an oven to determine its percentage by weight of the original sample. This analysis is done both at field laboratories and in Perth. All the records collected in the field are forwarded to Perth for processing and analysis. Since much of this processing is now done with a computer, the field data must first be converted into a form acceptable to the computer. Here, the information from a river level recorder is being converted and punched onto paper tape. The tapes are labeled and packed, ready for the computer. Other information, such as the relationship between river level and flow, is punched onto cards. The cards and tapes are assembled and taken to the computer. River level information punched on paper tape is fed into the computer. The computer has been programmed to edit the data and rewrite the information onto magnetic tape. Further information, including the river flow to stage relationship, is read in from punched cards. The computer is programmed to make various calculations and print out detailed information on the flow of the river. From many years of processed records, engineers can evaluate water resources efficiently and design projects for the benefit of all.